In this video, I'll discuss one of my illegal methods, nearby value substitution, a technique used in limits to simplify complex calculations. I will explain what it is, how it is used, and the limitations of nearby values. We will also demonstrate practical examples of how it can be used to reduce errors and increase the accuracy of calculations. If you don't know what I mean when I say illegal method, check the description. So, let's get started. Suppose we want to evaluate the limit of the function f of x equals x squared minus 16 over x minus 4, as x approaches 4. We know that direct substitution gives an indeterminate form 0 over 0, so we need to use a different technique. We can factor using the factoring method. So, x squared minus 16 can be written as x plus 4, times x minus 4. Our f of x now is x plus 4 times x minus 4, over x minus 4. We can cancel x minus 4 here. That will only leave us x plus 4. So now, we can evaluate our limits by substituting 4 in x. 4 plus 4 is 8. So, the limit of the function f of x equals x squared minus 4 over x minus 4, as x approaches 4 is 8. In this example, you know at the first glance that this is an easy problem since the numerator is the difference of two squares, and it can be cancelled. What if they give you a complicated equation that is hard to factor and using direct substitution gives an indeterminate form 0 over 0? What will you do? So I'll teach you this illegal method, the nearby value substitution. This method works even if you have zero knowledge of factoring. Let's try this problem. Limit of 6x cubed minus 5x squared minus 61x minus 60 over x minus 4 as x approaches 4. To use nearby value substitution, just substitute the approximate of the limiting value on the equation. In this problem, our limiting value is 4. Then, we can use 3.999 since this value is approximately 4, or you can use 4.001. You can use any of them. I will use 3.999 for this problem. Substituting 3.999 in the equation gives us 6 times 3.999 cubed, minus 5 times 3.999 square, minus 61 times 3.999, minus 60 over 3.999 minus 4. After computing this, we get 186.933006. This is approximately 187. So the limit of 6x cubed minus 5x squared minus 61x minus 60, over x minus 4 as x approaches 4 is 187. You may ask, why is the answer 187 not the other one? The reason behind this is that, if x is very close to the limiting value, then the expression will also be very close to its limit. The closer the value we use is to the limiting value, the more accurate the resulting approximation will be. We can try nearby value substitution in our first example. Our first example is the limit of x squared minus 16 over x minus 4, as x approaches 4. Our limiting value here is 4, so, we can use 4.001 since it is closer to 4. Substituting 4.001 to the expression gives us 4.001 square, minus 4, over 4.001 minus 4. We get 8.001. 8.001 is approximately 8, similar to our previous answer. This technique can be particularly useful when the function being evaluated is difficult to simplify or factor. So, the nearby value substitution technique can be used for any limit expression, as long as the function is continuous near the limiting value, and the limit exists. However, it may not always be the most efficient or accurate method, depending on the specific expression being evaluated. This is the end of the video. See you in another illegal methods episode.